It's lunchtime, and Aman is starving. He puts his cold leftovers into the microwave and hits start. When it finishes, the food is blazing hot and steaming. But strangely, the glass plate underneath is completely cold. How does the microwave know to only heat up the food, but completely ignore the glass plate? At school, his physics teacher explains that a microwave doesn't use fire or traditional heat at all. It uses light. Hidden inside the metal box is a brilliant device called a magnetron. The magnetron converts electricity into a very specific type of invisible light, electromagnetic waves. These waves sit right between radio waves and infrared light on the spectrum. We call them microwaves. They are exactly 12.2 centimeters from peak to peak. But why this specific size? To answer that, we have to look at the food. Almost all the food we eat is full of water. If we zoom into a single molecule of water, H2O, we see it has a very unique shape. Because of this shape, one side has a positive charge and the other side has a negative charge. It acts like a tiny magnet. We call this a polar molecule. When the electromagnetic wave from the magnetron hits this tiny water magnet, things get crazy. The electric field of the wave grabs the molecule. The positive side of the wave pulls the negative side of the water. But the wave is constantly alternating. A split second later, the field reverses, and the molecule is violently yanked the other way. The magnetron makes the wave reverse 2.45 billion times every single second. The water molecule is forced to flip back and forth frantically. Now imagine millions of water molecules all packed together in your food, flipping wildly and crashing into their neighbors. All that bumping and crashing creates intense molecular friction. And in physics, friction equals heat. This is called dielectric heating. The microwaves don't actually heat the food. They force the water inside the food to heat itself. So, why did the glass plate stay completely cold? The molecules in glass, ceramics, and plastics are locked tightly in place. They are not polar magnets like water. When the microwaves hit the glass, the molecules don't flip. The waves just pass harmlessly right through them. No flipping means no friction and no heat. But what about the metal box itself? Metal reflects microwaves perfectly, keeping them trapped inside the cooking chamber. As the waves bounce back and forth, they collide. This creates a pattern called a standing wave, which has extreme hot spots and dead cold spots. If your food sat still, half of it would burn and half would stay frozen. That is exactly why microwaves have a rotating turntable. By slowly spinning the food, it drags every part of your meal through those invisible hot spots, heating it evenly. So, the next time you warm up a meal, remember, you aren't using fire. You are using an invisible light show to make your water dance.